Building a simple REST API with Flask is one thing, but building a modular and scalable REST API with Flask is another. By the end of this video, you'll have built the foundation for a modular, scalable REST API using application factories, Flask REST-x, SQLAlchemy, and Marshmallow. Our example project is going to be an API for a blog where you can create, read, update, and delete articles. However, the example content isn't what's important. What is important is that you can adapt the logic and structure that we define to fit your application specific needs. So with that being said, let's get started. Create a new directory called blog API and initialize a new virtual environment. Let's go ahead and install some initial libraries that we'll need. Flask, which is our web framework, Flask REST-x, which is an extension for Flask that enables us to quickly build REST APIs, and last but not least, Black, which I'm going to use for code formatting, but feel free to use whatever you like. Once that's finished installing, go ahead and open the directory in your favorite text editor. I'm using VS Code. And we're going to create a package named source with a dunder init file, followed by a config module. We'll define all of our application config inside of config.py. And this is the same as using app.config, except we can define a config set for each environment and keep it all clean and organized here in this file. The config class is going to be our base config, which we're going to use to define some defaults. All the other configuration objects we define afterwards are going to inherit from this class. So we'll go ahead and set testing to false. And now we'll add our development config, testing config, which will override the testing value. And finally, our production config. We'll add more here later, but for now, let's move on to creating our application factory inside of init.py. We first need to import Flask, and then we can define a function called create_app. And inside of it, we will instantiate our Flask app. We'll set the development config we just created as our app's config. You can see that we have a source.config.development config, which perfectly maps to the source package, config module, and the development config object. Now let's set up a quick sanity check endpoint to test our setup so far. Let's import API and resource from Flask REST-x, instantiate our API, and define our first resource, which is just going to be a simple health check that returns some data when the get method is called. Then we'll add that resource to our API with an endpoint of /health. With Flask REST-x, we define our endpoints as resources, which give us easy access to multiple HTTP methods just by defining them on our resource. So as you can see here, we define the get method, which will be called whenever a get request is made to our endpoint /health, which is where we're going to return some test data for the time being. And then last but not least, we're going to return our app instance. Next, we'll extend the Flask CLI, which is used to manage our application from the command line by creating a manage.py file in our root directory. In this module, we'll create a new Flask group instance, which is going to extend the normal CLI with commands related to our Flask application. We can now start our app by opening the terminal and running python manage.py run. You can see that the environment is currently set to production and we want it to be development so we can properly debug. So let's stop the app, export flask_env equals development, and then rerun the application. As you can see, we're now running in the development environment. So let's open this link to check out our API docs. Flask REST-x automatically provides us with a Swagger interface, which we can use to test our endpoints and document our API. We can test our health endpoint by clicking try and then execute. And we did in fact receive the expected response. We can also test this endpoint the same way by just navigating to /health. Our sanity check is good, but let's do some refactoring and move our API endpoints to /API instead of the root URL. To do so, let's first create an API package inside of our source directory and add a module named health to it. Inside the health module, we need to import namespace and resource from Flask REST-x. Then we'll create a new namespace with the name health and assign it to API. We can then copy the health resource from our create app function and then assign that resource to our newly defined namespace, passing the health resource and an empty string as arguments. Empty string simply means that this resource will be at the root of this namespace. In our case, the end result will be /API/health, but /API does not exist yet. So let's define it inside of the init file of our API package. We need to import blueprint from Flask, API from Flask REST-x, and the health namespace from our health module, ensuring to import API as health_ns to prevent any naming conflicts. Then we'll create a new blueprint named API and a new API instance. And instead of passing our entire app, we're just going to pass that blueprint we created as the application for this API instance. We can also set some API configurations here as well. I've just set the title and description, but feel free to check out the documentation for all the other options. Now that we've created our new API, we can add our health namespace to it with the API add resource, passing in that namespace that we imported to that function. Great. So we've defined a blueprint and passed it to a new API instance. Now we can register that blueprint with our create app function. To do so, first, let's remove all the leftovers from our Sanity Check that we made here earlier. And then now we can import our blueprint from our API package and then register the blueprint with a URL prefix of /API. Let's test again by navigating to localhost 5000. We should see a not found error, but if we navigate to localhost 5000 /API, we should see our documentation, which we can use to still test our health endpoint. We can also navigate to our endpoint directly with /API/health. Cool. So now that we have an API foundation, let's begin to build on it by adding our articles endpoint. The first thing we'll do is define our article namespace and resources. So let's create a new file inside source/API and we'll call it articles. We'll repeat similar steps as we did with the health namespace, but we'll pass on all of our resource methods for now. The first resource we'll create is article list, which will be the resource for the root of our articles namespace. This resource is going to have two methods, a get and a post. The get should return a list of articles and post should create a new article. For the second resource, we'll name it article, and this resource will be dedicated to /articles/article ID, which will handle single article operations. Finally, let's add these resources to our article namespace, ensuring the proper URL prefix is used with each. Now we need to register this new namespace with our main API, which is located in source, dunder, and init. We'll repeat the same steps we did for the health namespace, importing the API as articles_ns, and then adding the namespace at the bottom. Let's verify that everything is working by checking out our Swagger documentation. Great. So we can see that all of our endpoints are here and they are grouped by namespace, and our doc strings are even populated here as well. We could test these out, but obviously nothing is going to happen as we're simply passing over each one of those methods inside of our resources. So let's change that by adding some additional functionality to our articles. We need to install a few packages before adding that functionality. We're going to be using SQLAlchemy as our ORM and Marshmallow for serialization and deserialization of our data. So now that those extensions are installed, let's register them to our Flask application. We'll start by creating a new module in our source package named extension, where we can instantiate all of our extensions. Now let's import those new extensions and instantiate them. According to Flask Marshmallow's documentation, our DB must be created before our MA instance, and MA is short for Marshmallow in this case. Just having these extensions here doesn't actually register them with our Flask app. To do so, let's create a helper function in our source init file. We'll call this helper function register extensions, and it will receive an app as an argument. We'll also need to be sure to import DB and MA from our extensions module. Then inside of our create app function, we'll call register extensions, passing it our Flask application. Now that those extensions are registered, we need to add some additional configurations for them. So to do so, we'll modify our config file. Inside of the config class, add a secret key and set the SQLAlchemy track modifications to false. This is going to prevent a deprecation warning that keeps popping up. Remember, each of these other classes inherits from this one, so unless the values are overridden, they will each have these configurations. We're also going to add SQLAlchemy database URIs using SQLite to each one of our configurations as well. And the great thing about using an ORM like SQLAlchemy is that we can change our database to another type in the future without having to change really any of the configurations within our code. I will make a note here, you should never store any secret keys in plain text inside of your configuration if you're planning on publishing the application or pushing the repository to GitHub. Always retrieve your keys from a more secure source. So now that we have our configurations updated to support our SQLite database, let's start to work on our articles functionality. We'll start by creating a new package inside of our source directory named articles. We'll then create the following modules inside of that. Models, which is going to hold all of our database models, schemas, which will hold our Marshmallow schemas, and services, which is going to hold all of our additional business logic. Let's go ahead and define our article model inside of models.py. I know that we're going to need a timestamp, so let's import datetime and time zone from the datetime library. We'll also need our database instance, so let's import that from source. To clean things up a bit, I like to alias some of the common database names, so I'll set column to db.column and model to db.model. We'll then define a class named article, which is going to inherit from model. Then we'll set the table name for our database, which is going to be articles. And this was actually going to be created inside of our database. Now let's define our database columns and data types. We'll have an ID column, which is going to be an integer data type and used as the primary key. This will automatically increment by default as we add new articles. We'll define a title column, which is going to be a string data type. The max length we'll set to 255 and we'll set nullable to false. Next, let's define our content column, which is going to be a text data type, which is a variably sized string type. And we'll also set nullable to false on that column as well. Lastly, we'll define a created@ column, which will store a timestamp of the creation time. It will be a date time data type, and the default will be set to the current time. We'll also add an init and a repr method. The repr will only show the first 10 characters of our article content, as well as the article title, of course. Now that we have our database model defined, we can initialize our database. To do so, let's add a command to our manage.py module called recreate DB. This command will drop all existing tables if they exist, and then recreate them and commit commit the session. It's very important that we import our models here because if not, the tables will not be created. If we run the command python manage.py recreate db, we can see that our articles table has been created and it includes the appropriate columns that we defined in our article model. So now that we've defined our resource routes and our database model, let's move on to defining our schemas, which Marshmallow is going to use to serialize and deserialize our data from Python object data types into user readable JSON data types. We'll start out by importing our Marshmallow instance from our source package, and then we need to import our model, which Flask Marshmallow is going to use to automatically generate our schema. We'll call our schema article schema, and it will inherit from ma.SQLAlchemy auto schema. Then we'll define our inner meta class, setting the model to our article model, load instance to true, and order to true. Now we can instantiate our schema with article schema equals article schema, followed by article list schema equals article schema many equals true, which will serialize and deserialize lists, aka for our getAll methods. Finally, let's move on to the article services, which are going to handle all the business logic. If we look at our article resources, we can see that we're going to need a few different services. We're going to need to retrieve a list of articles, create a new article, get an article by its ID, update an article by its ID, and delete an article by its ID. So let's get to work, starting with creating an article. We'll first need to import our database instance from the source package, as well as the schemas we recently created. Then we can define a function called create article, which takes in serialized data as an argument. In our case, the serialized data is going to be a dictionary created from the JSON request body. We're then going to deserialize that data with article schema.load, passing in the data, which is going to convert it to an article instance. And then now that we have our article instance, we can add it to our database. So now that we have an article instance, we can't return it back in a response. So we'll have to return a serialized version of it with article schema.dump article. And then we're also going to return a 201 created status code. Now let's update our resource so we can actually test our endpoint. First, we're going to define the fields inside of an API model, which is going to be used within our API documentation. Once we have those fields defined, we can use the decorator API doc body equals article fields, which will render the appropriate fields in our Swagger interface. Finally, let's import requests from Flask, which is going to give us access to that request body, and add our create user function from our services module to this resource method. Now when we test, we should get back a successful response with a created timestamp and ID, and we do. So let's create a few more articles and then work on the other services, starting with getAll articles. Now we'll use the article list schema to dump our deserialized database objects into a serialized list of dictionaries, and then we're going to update our resource to return the getAll articles function. Let's quickly make sure to test and see if that works, and it does. So let's wrap up the remainder of our services now. The get article service takes in an article ID as an argument, and it queries the database to check and see, does this article exist? If it doesn't, it's going to return a message saying article with that ID is not found with a 404 status code. But if it does find an article, it's going to run that article through the serialization and then return it to the user with a status code of 200. The update article service is going to take in an article ID and data. Data is the serialized request body that the user passes with their put request. It also checks to make sure that the article actually exists first. If it doesn't, it's going to return that message with a 404 error. If it does exist, we're actually going to deserialize the data into our instance of article and then say partial equals true, which basically means it could not be a full replacement of the object. So the users are only going to have to put in a title and content, but there's obviously going to be an ID and they created that date inside of that as well. So we say partial equals true, and that's going to actually load that instance and update the instance. So now currently as it stands, article is that updated article. So we need to commit the database session and then return that article back to the user in a serialized fashion with a status code of 200. And then lastly, we have delete article, which just takes in an article ID as an argument. We're also going to first check to see if the article exists. If it does, we're going to delete the article and then commit the database. We're going to return nothing with a status code of 204 for no content. Now we can update all of our resources by importing our service functions in and then applying them to each of the respective resources. Now let's test out our API by navigating to our Swagger documentation. So we'll first check our get all articles again, just to make sure it still works, and it does. We get the expected response. Next, we'll create a new article and we'll just put some test dummy data here, and the request looks like it came back successful. But now let's try to get some articles by IDs and see what happens if we get some valid articles, and also to make sure we get the proper error response if we try to get a non-valid article ID. And as you can see that it does in fact give us a 404 error not found with a message saying article with ID 4 does not exist, which is the article ID that we passed into the request. Next, let's try deleting an article and make sure that works as expected. And as you can see, when we get all these articles, we lost that article that we had just deleted, which that means is working correctly. And when we try to actually run the put method on our articles, we can see that we don't have those fields here available for us to pass pass in. Now this would still work if you were using an HTTP client that wasn't the Swagger documentation. However, that shows you exactly what the @api.doc decorator does. So let's go ahead and add that to our put method on our resources as well, and then try again. So as you can see, we updated the ID too. And when we get that ID afterwards, we can see that it does have our changes that we made reflecting inside of that GET request. And that's going to do it for the foundations of our REST API with Flask REST-x, SQLAlchemy, and Marshmallow. I hope this has been informative. If you found this video useful and you'd like to see more content like this, be sure to like and subscribe. It helps the channel out a lot, and I will see you all in the next video.